Partial pressure and Kp. Introduction to Kp and partial pressure. If reaction has gases, a different equilibrium expression can be set up using partial pressure of gases instead of concentration. Partial pressure. Partial pressure of gas in mixture is pressure that gas would have if it was the only one that was in that volume. If mixture of gases has 3 different gases, then the total pressure will equal the 3 partial pressures together. Partial pressure equals mole fraction multiplied by total pressure of gas 1. Mole fraction. Mole fraction equals number of moles of a gas divided by total number of moles of the gases. Kp expressions. Kp is equilibrium constant, and the P means partial pressure of the gas. Don't include solid, liquid, or aqueous substance, only use gases. Kp for the Haber process, which is P ammonia squared divided by P nitrogen, which is multiplied by P hydrogen cubed. Don't use square brackets, as square brackets are only for concentrations. Kp units. Write the units and then cancel out units. Example is Kpa to the power of 2 over Kpa to the power of 4. When it's simplified and canceled out, it forms Kpa to the power of -2. Heterogeneous equilibria for Kp. Kp expression only has gaseous substances. Any substances in another state are left out. Effect of changing conditions on value of Kc or Kp. Larger K, P means greater amount of products. If Kp is small, we say equilibrium favor reactants. Kc and Kp only change with temperature. They don't change with concentration or pressure or catalysts. Effect of temperature on position of equilibrium and Kp. Position of equilibrium and value of Kc or Kp will change if temperature is changed. When forward reaction is exothermic, if temperature increases, the reaction shifts to counteract the changes made is the system and moves in endothermic direction. Position of equilibrium shift left. So, value of Kp gets smaller as there are less products. Effect of pressure on position of equilibrium and Kp. Position of equilibrium will change if pressure is changed. Bit value of K, P stays constant, as K, P only changes with temperature. In equilibrium, which is few moles of gas on product side. If pressure is increased, the reaction shifts to counteract the changes and move in forward direction to side with less gas moles. Equilibrium shifts right and value of K, P stays same, but only temperature changes value of Kp. Increasing pressure doesn't change Kp. Equilibrium shifts to right, increasing mole fractions of products and decreased mole fraction of reactants. Top of the Kp expression increases and bottom decreases until original value of Kp is restored.